That's fine. Okay, folks. Let's go ahead and get started. First things first, I was going to take a minute and discuss Thursday, which is your first exam. And how I expect, what I expect you to do, that type of jazz on your first day or during exams. What I'm going to describe is what will be happening every exam, except for the fact that I will be here except for the first. So the first thing I want to mention is I will not be here on Thursday to proctor the exam. Dr. Lei Yang will be proctoring the exam. Now, what I'm going to describe next is what I expect for every exam though. Number one, you will be expected to spread out. Other than on this first row, I expect no more than 3 people on each portion of the row from there on. So 3, 3, 3, 3, 3, 3. And you will have a seat in between each of you. So that is number one. Number two, you are to turn your cell phones off or on silent, and they are to be placed in your backpack or whatever. And your backpack and anything and most items will be against the wall. So in other words, the only thing you should have at your desk is a pen or pencil or both. You can have highlighters, your calculator, and a drink and food's fine. After that, after everything is put away, Dr. Yang will pass out the exam plus the conversion sheet. And when you receive your exam, you're to remove the last page of the exam. That last page contains your formulas, and it also contains your periodic table. When you turn in the exam, I don't want the formulas, I don't want the periodic table, and I don't want the conversion tables back. I just want the exam itself. Any questions about Thursday? Now, this first row is the only row where there may be people sitting beside each other, but the rest of the rows, there will be a seat in between each person. Second thing, I am going to give you insight into your exam, which is right here. So if you want to take notes, be prepared. I mean, you could look on Blackboard too, but I do have it sitting here. Number one, you will have a table where you have to indicate the charge, the location, and the responsibility of each of the subatomic particles. The charge, location, and responsibility of each subatomic particle. You will have one question over what we will go over first thing today, and that is average atomic mass. Question 3 has 3 different parts, but it is related to understanding isotopic symbols. You will receive several of these blank periodic tables on the exam. In those, you need to, and I believe there's like 7 or 8 of them. On those, I will be asking for specific information about how the periodic table is arranged. So in those cases, you will need to be able to separate metals, non-metals, metalloids, transition metals, main group elements, intertransition metals, groups, periods, stuff of that nature. Alkali metals, alkaline earth metals, halogens, and noble gases. Now be careful on those questions because at times I ask you to write in the element symbol. At other times I simply ask you to shade in all of the elements. So read the questions. You will have a question that has 5 parts where you have to tell me how many significant digits are in a number. You will have a question with 2 parts where you have to perform a calculation and give the answer in the correct number of significant digits. You will have a question with 3 parts where you have to read an instrument and record to the correct sig figs. You will have a question where you have to perform temperature conversions. Yes.
Do we have to do 2 things on
No. You only have to do significant digits on the questions that I tell you significant digits are required for. Question 16 is a table. It asks for element symbol, element name, number of protons, number of neutrons, number of electrons, atomic number, mass number, and isotope symbol for 4 elements or 4 isotopes. Question 17 is a conversion involving density as a conversion factor. Question 18, you have to calculate the density of an object. Question 19 is a conversion using English conversion factors. Now, I will give you a warning on that one. When you look at your conversion table, you would notice that I nicely divided things into length, mass, volume. Make sure you're using the right section of the conversion table. And question 20 has 3 parts. And it is metric to metric conversions. They could be 1 conversion unit, 2 conversion unit, or cubed, squared conversion units. But it's metric to metric. My exams are long enough that if you don't know what you're doing, you will not finish it, but they are short enough that if you know what you're doing, you'll probably be out in 30 to 40 minutes. Also, show your work on everything. The reason is I give partial credit. But if there's no work, I can't give partial credit. So for instance, on those conversions, if you set everything up correctly and just get the answer incorrect, that's only like -1 point out of 5 points or 6 points. So setting it up, showing me your work is important because it could give you partial credit. Questions? Okay, the next thing I am going to do is I'm going to pass back quiz 1, quiz 2, and if you did the first bonus opportunity, which by the way, there's another one tonight. If you did the first bonus opportunity, I'll pass that back as well. And while I pass back stuff, I will send around the sign-in sheet. With the sign-in sheet, as always, make sure you sign in because this is how attendance points are determined. Let me start here because it'll be easier to do the whole song. Okay. So, and there's a couple I had a little bit of trouble reading on names, and I think I made a mistake. Well, I'm fairly certain I made a mistake on one because I've already been called out on it. But most of your handwriting I could easily read. And one of the things that I'm doing, one of the things I did, one reason I kept quiz 1 for so long is because I have gone in and entered your favorite song into my radio for loud. So that way we can have everybody's favorite songs also, including mine. And I'll reduce some of mine. But that way, you know, I was trying to do things that would be fun. Okay. And let's hope I can say all names now. Reagan Barrier. Reagan. Ashley Bell. No, I'm sorry. That's
No,
my
you're
fault. I read it rather quickly. Ashlyn Bell. I will get better. Aiden Bird. Kinsey Blanchard. Emma Brown. Jair Canales. Canales? I remember the first name and now I'm like, I can't remember the second name. Catherine Carter. Christina Charles. Christina. Bridget Freeman. If I say any name wrong, let me know. I'm getting first names, I think. Conlon Doss. Peyton Eman. Alex Fields. Therese Flood. Harris. So the Y has a U sound. Okay, I'll work on it. David Ginger. Jack. Let me make it myself a note real quick on yours.
I know my signature is terrible, I'm sorry.
Oh, I remember to give it to you.
Thank you so much.
Caitlin Hanson. Layla Harden. Lily Hood, not just you. Zoe Hubbs. It wasn't just you. There was another one that I couldn't read either. Landon Humphrey. Now that I know what it looks like, it'll be easier. Regina Johnson. Regina. Kylie Jones. Cameron Joyner. Cameron. Kinley Keith. Wesley Lanius. Ton Mai. Martin Martin. Kyle Payne. Kennedy Pilkington. Gotta trust myself. Tyler Penny.
Yeah.
Abby Rains. Abby Rains. Tyler Reed. Alexis Reedy. Sophia Renegantala. How bad did I butcher the last name? Oh, yay. Ty Rings. Alejandro Sanchez. Logan Sanders. Brooks Medley. Kinsley Sophos. Savannah Stallings. Rin Ting. Tang? Tang or Ting? Tang. Okay. Amelia Young. Amelia. Okay. I had one person turn in a bonus opportunity with no name on it. Time? Okay. Let you come grab it. That should get all of that up to date. I am working on your bonuses. I mean, not your bonuses, but your labs. And I hope to have them back to you next week. So. Any questions for me about everything I've done so far? Yes. You can turn it in Tuesday. Just turn it, yeah, if you do the bonus tonight, just turn it in next Tuesday when I'm back. That way Dr. Yang doesn't have to question what's going on. The bonus points don't apply to the very end. So basically what I'm doing is you can earn up to a 3% curve on your overall grade rather than on a test by test basis. So yeah, I keep track of them on a separate sheet until the very end, and then I upload all of them. Same thing with attendance. I won't upload the attendance until the very end. Comes forward. Okay, any other questions for me? Okay, so today we have several things we need to try to cover. The first that we're going to cover is the average atomic mass. The second thing that I'm going to cover is going to be Avogadro's number. Which means we'll look at the molar mass and compare to the formula mass of an element. And then we will start getting into the nature of light, which is the starting point for our discussion related to where the electrons reside in an atom of an element. Now, before I get into the average atomic mass, I want to just do a quick recap of a few things that we discussed on Thursday. First of all, you have the atomic number, which is found on the periodic table. That atomic number is equal to the number of protons, and it is equal to the number of electrons if we're talking about a neutral atom of an element, which is the only thing we've discussed to this point. The other thing we discussed is a mass number, which is not on the periodic table. And the mass number is equal to the number of protons plus the number of neutrons. Folks, in order to get the mass number, I either have to give you the mass number or I have to give you the number of neutrons. You're not going to be able to get the mass number any other way, because the mass number is not on the periodic table, which again, I've got to break everybody of that habit. It is not on the periodic table. Then the other thing we talked about are possible isotope symbols. Which include X, which could be any element symbol up there. It's just a placeholder. The mass number is listed as a superscript to the left, and the atomic number could be listed as a subscript to the left. But the element symbol and the atomic number, basically, if I have both, I'm essentially repeating myself. Because if I look at the element symbol on the periodic table, I find the atomic number. Because carbon, element symbol C, its atomic number is 6. Or atomic number 6 is carbon. It's a repetition. So more often, you're going to see it written as simply the element symbol with the mass number. Or sometimes you will see it written as the element symbol followed by the mass number. These are the 3 forms of the isotope symbol. In order for it to be the same, and then finally, the last thing I just want to reiterate, and I'm reiterating a few of these things because I've had multiple questions come up in my office. I just want to reiterate the 3 subatomic particles. So the number of protons, protons, electrons, and neutrons. Protons are a +1, They're found in the nucleus. They are responsible for an element's identity. And they are always the same. So the atomic number must always stay the same because the number of protons must always stay the same. The electrons in a neutral atom, you will have the same number of protons as electrons because they are the same value but in opposite sign. The electrons are in the electron cloud, and they are responsible for an element's reactivity. And finally, the neutron has no charge. It is found in the nucleus. And ultimately, it is responsible for the isotope of the element. So if I'm completing this table, it would be charge, location, responsibility. So I just wanted to recap because I had multiple people asking me those questions. And so this finishes up that nice and tidy little neat pile, I hope. I emphasize this because, again, there is a difference between the mass number and what is known as the average atomic mass, which is found on the periodic table. If I asked you how to calculate, if all we had in this class were exams, and they were all worth the same thing, and I asked you how to calculate the average grade in here, what would you do? You would take into account all of the exams. In this particular case, you would add them all up and then divide by the number of exams. But my point here is you take into account all of the exams. Well, we're talking the average atomic mass. We got to take into account the isotopes. So the average atomic mass takes into account all naturally occurring isotopes and their abundance. The way we calculate this is that the average atomic mass, and this equation is given to you on the exam, is equal to the sum, which is what the capital sigma means, the sum of all naturally occurring isotopes of the atomic mass for that isotope times its abundance. To see this in action, let's take nitrogen. Nitrogen, if I go and dig up a sample of nitrogen, no matter, or not dig up, I guess, if I go and capture a sample of nitrogen from the atmosphere, that's more realistic. I would find two isotopes of nitrogen. I would find isotope nitrogen 14 and isotope nitrogen 15. Nitrogen 14 has a mass of 14.003074, whereas nitrogen 15 has a mass of 15.000109. And no, you're not expected to know this information. I have to give you all of what I'm about to do, and then you just perform the calculation. If I go dig this up, (99.632% of my sample will be nitrogen 14. The other 0.368% will be nitrogen 15. Now, I'm going to look back here. It said the atomic mass. I have the atomic mass, but it specifically stated abundance. I don't have just pure abundance. I have percent abundance. So I am going to take that percent abundance, and I am going to take it out of percentages to be abundance. That way, I can perform the calculation that it gave me. So, our nitrogen 14 it contributes 13.952 to the overall mass, whereas nitrogen 15 contributes 0.055 to the overall mass. So the mass of nitrogen is 14.007 AMUs. And the way I did that is I followed my formula. I took the mass and I multiplied it by the abundance. I took the mass and I multiplied it by the abundance to get its contribution. And then I did the same thing for nitrogen 15. And then you simply add the two together because, again, that sigma is sum. Let's look at one which isn't so, oh, by the way, now, I said the average atomic mass by my calculation came out to be 14.007. That's where that number came from. It rounds to 14.007. Let's look at one more example. Let me find one that's not so cut and dry. Okay, let's do this one. Let's go with magnesium. Magnesium has three, and that's magnesium 24, magnesium 25, and magnesium 26. By the way, I just want to state, while nitrogen and magnesium, their isotopes are in order, that's not always going to be the case. It just happens to be the case for the two I picked. So with magnesium, the first one has a mass of 23.985042 and occurs 78.99% of the time. The second one has a mass of 24.985837 and occurs 10% of the time. And the last one has a mass of 25.982593 and it occurs 11.01% of the time. Taking my percent abundances and just converting them to abundance in preparation for this calculation. The first one is 0.7899, the second one is 0.100, and the last one is 0.1101. And now I'm ready to do the math. Magnesium 24 contributes 18.946 to the overall mass. Magnesium 25 contributes 2.499 to the overall mass. And magnesium 26 contributes 2.861 to the overall mass. Adding them together, I get a mass of 24.316, which that one over there should be 24.305 something. In other words, it's not going to, mine may not come out exactly perfect, folks. And that is because it's all dependent upon where you get your percent data, but it's going to be pretty darn close. It may not be exactly perfect. It may be a difference of they use slightly different percentages or went out to greater numbers, or there's a variety of reasons why it might be slightly different, but it should be pretty close to what's up there. Questions? And the unit on this is AMUs. AMUs stands for atomic mass unit. And atomic mass units are going to be considered for a single atom of the element. Now here's the problem. We are unable to manipulate one atom of an element at a time. only in the last probably 30 years, which I know is older than most of you have been alive, but only in the last 30 years have we actually been able to start to see a single atom of an element. But to date, we cannot manipulate a single atom of an element. So how can we handle this? An individual by the name of Avogadro came up with a way to take AMU, which is for a single atom, and get that into grams. So for example, our, I'm going to use this periodic table because I can see it better. Vanadium, a vanadium atom has a mass of 50.94 AMU. But if instead of talking about AMU, we want to talk about 50.94 grams, what is that? Well, come to find out, if you have 50.94 grams, that's going to be equal to 6.022 times 10 to the 23rd atoms. Let's talk aluminum. Aluminum is 26.98 AMU. But if instead we want to talk about 26.98 grams, that winds up equal to 6.022 times 10 to the 23rd atoms. Iron has a mass of 55.85. Yeah. 55.85 AMU for one iron. But if we talk in terms of grams, that 55.85 grams is equal to 6.022 times 10 to the 23rd atoms of iron. In other words, an atom, now this number, 6.022 times 10 to the 23rd, is known as Avogadro's number. And 6.022 times 10 to the 23rd of anything, we're going to say X, is equal to 1 mole of that thing. 6.022 times 10 to the 23rd green peas is equal to 1 mole of peas. 6.022 times 10 to the 23rd marbles would be equal to 1 mole of marbles. In other words, 6.022 is a counting number. I have one atom, I have two atoms, I have three atoms. Until I get to 6.022 times 10 to the 23rd, and then I'll have a mole of atoms. It's like 12 eggs and a dozen eggs. It's a counting number. Because it is a counting number, 6.022 times 10 to the 23rd is going to not factor in to conversions for sig figs. 1 mole will not factor in to conversions for sig figs. Now, what I have here is I have 1 mole of aluminum. I'll start it passing around. That's aluminum. I have 1 mole of iron. Pass it back. It'll be easier to pass it back around. I have 1 mole of copper. I have 1 mole of zinc. You will notice differences in size and differences in weights. But it doesn't matter if the size is different. It doesn't matter that the weight's different, folks. Those blocks I'm passing around contain 6.022 times 10 to the 23rd of that element. In other words, Avogadro's number can be a conversion factor. If I had an example, how many atoms of zinc, since I'm passing it around, is found in (21.235 grams of zinc. Okay. First thing I'm going to do is list out what I was given. I was given 21.235 grams of zinc, and I'm going to list out what I want. I need atoms of zinc. Now, before I can answer this question, I have one more definition I need to give you. And I'll do it up here. And that is, we need to talk about the molar mass. If 6.022, if 6.022 times 10 to the 23rd atoms is 26.98 grams, and 6.022 times 10 to the 23rd of anything is 1 mole of that thing, then we can say that 1 mole of aluminum is equal to 26.98 grams of aluminum. If 6.022 times 10 to the 23rd atoms of iron is 55.85 grams, and 6.022 times 10 to the 23rd of anything, I did a horrible job of that, is equal to 1 mole. That would mean 1 mole of iron is equal to 55.85 grams of iron. This is called a molar mass because it has the term mole in it, and it also has the term mass in it. So that's where it comes from. Now, I needed to introduce that because when I see grams, I'm automatically going to think my conversion factor is going to be the molar mass. If you see grams, your conversion factor is molar mass. So for zinc, because I saw grams of zinc, I know that I need the molar mass of zinc, which is 65.38 grams of zinc is going to equal 1 mole of zinc. If I see the term atoms, atoms means Avogadro's number. As the conversion factor. So since I saw atoms, I know that I'm going to be using the fact that 1 mole of zinc is equal to 6.022 times 10 to the 23rd zinc atoms. Well, you don't have to do that on this. You could have done a quicker route. You'll be glad to learn this method later on when we get into more complicated conversions, because I'll be using the same method. So in other words, I need 2 conversion factors. I'm going to start with the information I was given, 21.235 grams of zinc. My first conversion factor needs grams of zinc, so I'm going to use the molar mass. The gram of zinc portion will need to go in the denominator so that the unit will cancel out, with the mole portion going into the numerator. I will then convert that moles of zinc into atoms of zinc using Avogadro's number. Of Avogadro's number, the 1 mole of zinc must go in the denominator so that the unit and the substance will cancel out, leaving me atoms of zinc for the numerator. And now I'm ready to perform this calculation. And you should get a value of 1.956 times 10 to the 23rd zinc atoms. You can always check. Well, at least reasonably check. 21 is about a third of 65. And 2 to the 23rd is about a third of 6 to the 23rd. So you know you probably did the calculation correctly. Let me give you one. Oops. I mean to do that number. What is the mass in grams of 1.602 times 10 to the 24 atoms of sulfur? Okay, let's look at it. First thing I noticed is I had atoms. For me, atoms means Avogadro's number. Every time I see the word atoms. The next thing I noticed this thing acts weird sometimes. The next thing I noticed is that I needed grams. Grams means I need the molar mass. So I went and found those numbers. I started the equation with the piece of information that I was given, which was the sulfur atoms. I used Avogadro's number first because I needed to cancel out the sulfur atoms, leaving me moles of sulfur. And then I used the molar mass to go from moles of sulfur into grams of sulfur. Using the molar mass, I placed the moles of sulfur in the denominator so that they would cancel, leaving me ultimately grams, and it comes out to be 85.29 grams. Again, you can kind of check to see if this makes sense. Sulfur is about 32. And so I was thinking about this, 16 is, you got to keep in mind that this is a higher number, so it's a larger number, so it should be at more than double. Because double would be 1.2 times 10 to the 24, so it should be more than double. So that's why it seems like it's a valid answer. Questions? Yes.
Are you wanting us to round 2 decimal places for the molar mass every time?
That's all I have here. So it's dependent upon the periodic table I give you. This one just only has 2. So.
Could you go back up to the last one? You just need to write like one thing down.
Okay. I don't have time to introduce the nature of light. And so that'll have to wait until after the exam. What I do want to say though about the exam, so I will be here today. I will be here tomorrow. But if you were to, I've added everybody that gave me information at the beginning of the semester to a GroupMe. You'll have to find it. But if you have questions, you can start using that GroupMe because other people may have questions too. And I'll try to answer it in the evenings. But otherwise, I'm not going to try to get into the nature of light simply because, well, time. And I like to make the conversation complete. Any questions? Yes. No, you're not going to have to do sig figs when you do problems like this. I try to sometimes, but you don't have to. I try to think about it when I'm doing them. So the question is on the exam when you're supposed to do sig figs, will it say use sig figs? And yes, every single time I mentioned use sig figs. So if it doesn't say, you don't have to. Other questions? Yes. Now Ed puzzles, active, lab, where you have time to actually think about it. Sig figs are required, but I know that on a test it can get stressful. And so you may not have time to think about sig figs every single question. So that's why on exams. So the only time we don't have to do it is on exams.
You said you made the GroupMe already?
Yes.
Okay, I don't see it.
It may have gone to sleep if you didn't respond because I made it a week or 2 ago.
Oh.
So let me see. Whoops, not that thing. It's this thing. There's my college compliant GroupMe. Those are all the names that I put in. You can see if you were at it.
Yeah, since I was.
So let me see if I can resend it because that's the question now.
Did you put my number in right?
Yeah, I think so.
I'm sure you did.
I mean, it's always a possibility that I did.
Can I check?
Yeah.
I think if you go there.
Yeah. Well,
Then
there's
we'll-
another way. Brown. So these. That won't do it, but let's see if I wound up putting you into my phone contacts.
You ready for?
Yeah. I didn't even get your name into my things.
Yeah,
What?
yeah, we have Kim and Violet something. Yeah, he has. Yeah, he just told us like 4 things that are gonna be on our test. That's literally all he's mentioned.
Right.
Mm-hmm.
That's what he's so, he asked to. That's why he's.
Let's try this.
Yeah, we have this and that on the same day. And we have it for more than once on the same day. And then on the one we don't, have a calc exam that day too. Mm-hmm.
Just a lovely letter.
So happy. So much homework to do too. Do you have the paper for honors yet?
Yeah, but it's not due like 22nd.
We have our first draft due Monday. Mm-hmm.
I don't know what's going
Guess
on
I'm
because
going
I
to
don't
this weekend.
know.
Could you try adding?
You can add Emma to groups, but you can't send direct messages to each other until she downloads the GroupMe app.
I have GroupMe.
You are in a group, so I don't know.
You
Let's
could
see.
remove me and then re-add me.
Oh,
Are you remember me?
sometimes if you don't reply, it does weird things.
I have so many GroupMes.
I know.
Well, it's just because of honors. We literally have 4 GroupMes for honors.
I just re-added you. Okay, let's try this thing.
Those Zoom today?
Remove.
Do what?
There's the,
Okay, give me your number, Emma.
No, I'm not doing that. 501 425 4490.
Maybe I typed it in.
Yeah, the thing
wrong.
Kyle's doing, the
yeah,
the algo decay thing.
yeah.
No, I will be doing the chemistry bonus thing and doing my mountain of homework.
Try that one.
Aha.
Okay, so I must have used your number.